Welcome to lecturer and fellow friends. So today our group will present the project presentation. My group is from group 8 and the team members is me, DINA SOFEA binti Muhammad NADZRI, AHMAD Ashraf bin Muhammad ZAMANI, Muhammad RaFiq SyiMir bin ROZI and NURUL IZZATI BINTI AMINAKBAR. So I will continue with the content of this project presentation.
Introduction. Technologies, especially Python programming, is vital today for automating tasks across various fields. Python programs boost productivity by reducing manual works, offering a simple, customized interface, and using extensive libraries of files, operation and system activities. This program automate repetitive tasks, streamline workflow, and support complex functions like error handling and schedule making them essential tools for improving efficient in daily operation.
My name is Dina Sofia binti Muhammad Nazri. My matrix number is CF220194 and my part is to explain the background of study. So as we know, Python program is used to develop a statically determinate beam that is required to calculate the support reaction, fixed end moment, shear force and bending moment. So we use this Python program to get the answer for statically determinate beam and use of fixed end moment to beam segment 8 in determining internal force, specifically shear force and bending moment and at the various points. So from the question we have point A to B, B to C and C to D. So from that point we can get the reaction force. And this simplification allow for simple internal force calculation and allow engineer to construct correct shear force and bending moment diagram. So by doing this Python program, the engineer can get the answer very quickly and fast and less error. So that's all from me. Thank you.
Next, I will continue this presentation with the problem statement for this project. Algorithm programming is the process of defining a computer's action to solve problem or perform a task. It transfers a set of instructions to the computer, which execute a series of instructions based on input. The output or result is generated after processing each input. Programming algorithms have logical steps for each phase, aiding in debugging. Next, we have three main objectives for this project. First of all, to arrange data using the pseudocode and flowchart. Two, to create a Python code that can determine the support response for a given statically independent. And last but not least, to create bending moment diagram (BMD) and shear force diagram (SFD).
Okay, hi. So this is a methodology for coding our coding. So firstly, I'm doing this flowchart for your code of our project. So first is start, and then second we need to input length of span ABC, CB, and CD. And next we go to the classic SK, and then we need to find KBA and also KCD, which is equal to 3EI over L, and so on until KC equals to KCB plus KCD. And next table for coding use SEO code of our project is calculate the distribution factor, which is DF. So to calculate the DF, the formula is K divided by DT. So end of period is like DF equals to 1. So maybe like in our course, in our project, they fix. So DF equals to 0. And next we calculate the display stiffness total and the distribution factor of AB, and we need to find the BA, BC, CB, CB, and also CD. And then next we, after that, finish the display the stiffness total So we need to calculate the end moment, which is the FEM, using the moment distribution method. And next, and then the coding also will display about the table moment distribution method, and also display the stiffness, total stiffness table distribution of factor of AB, BA, BC, CB, CD, and DC. And next, the the coding will show, I mean, like, will appear to calculate the end moment using moment distribution method, and display table moment distribution method also. Then after that, after the coding show the display table, so we need to calculate the support reaction. And then after we finish the calculate support, the coding will display support reaction. And next, display shear force diagram and bending moment diagram. So that's all. Okay, hi. This is me again, Ashraf. So this is a basic of coding flowchart of our project. So it's not it's different with the PCO code, the flowchart project. Like just now I explained to you. So this is the basic flowchart. Like, first is start, compile and evaluate the project specification, talk about tasks given with the group, create procedure code and the flowchart, put the code into the action, execute the code, and end. So that's all.
Next, for the manual calculation. First thing first, we need to decide the point load value and the distance. Then we can calculate for the fixed end moment for each member. Then we set up a table for easy to calculate the stiffness, total stiffness, and the distribution factor for the each member. Then the next paper, calculate the distribution factor, FEM distribution, and carry over for the each member. Calculate the data to the closer zero and total up from the FEM to the last data distribution that closer to the zero. Next, after the calculation in the table, we need to calculate all the reaction that we have, and then draw the support, draw the diagram that we chose, and start draw the bending moment diagram and shear force diagram due to the support for each member.
Okay, this is result from Python. As we know, we get the distribution factor and the stiffness, which is K for each member. That is AB, BA, BC, CD, CB, CD, and DC. So these are the distribution factor and stiffness value for the member. Okay, after that, this is the table that we get from our coding. So in this table, we just add the join, the member, the distribution factor, the FEM, which is fixed end moment, and the balance for each distribution factor. So after that, after finish all the calculation, we summarize and we can get this shear force diagram for span A and B.
As we can see, the picture in this slide is the bending moment diagram that will generate from the Python program.
Okay, for the discussion, it's calculate support ration, fix and moment and shear force diagram and bending moment diagram. That's the outcome that we get from our coding. So after that, we utilize equilibrium equation and the section approach of simplifying beams analysis. We compare manual competitive with Python program for a structure with uniform distribution load and use the moment distribution method to produce accurate shear force and bending moment diagram. So that includes a pin roll and fix end approach for determining support ration and finally moment. So they demonstrate that Python calculate match manual result. So that the coding that we use from the Python and the manually calculation from our group, it's same. So that's the coding is right. Okay, lastly, the conclusion, the BFC20802, which is the computer programming subject project, has shown how Python automates beam analysis, making it easier to calculate support reaction, fix and moment, shear force, and bending moments. This increase productive and reduce manual works. The project used both method, manual and Python, for analyze structure with uniform loads, finding the Python automated calculation to accurate then match manual result. So the Python libraries and easily interface make it essential for structure analysis. So that's all from our group. Thank you.